So following that, we have got the timings. It's all about the timings. And from the developer's point of view, I don't think this is really very required for us, because as I said, most of the time we'll end up using the library of the manufacturer or some open source or written by some clever people out there. We got Mifare Ultralight ECK and AK. Again, it's good for the knowledge, but it's not very much required from the developer's point of view. And the next is the explanation about the various commands. So one of the very popular Arduino library is this one. So it's Arduino RFID library for MFRC 522. So MFRC 522 is a RFID reader writer manufactured by NXP, and this library takes care of all those timings and all those error codes. So even though this library doesn't allow or doesn't have all the commands introduced in the latest version, like get version and other things. So if you see the coding of this library, you will get an idea about how to write your own functions. And looks like, even though it is available as an open source, looks like it's completely unlicensed, so you're allowed to modify. Please read this before you start using. So what I understand is it's available for both commercial, non-commercial, and so a lot of things are here. So the first command is the get version. So this is something to do with the versionality check. So when you pass this command, just I'm going to explain you a couple of commands. So again, this command is not available in the library of MFRC 522. But if you want to use this command, you have to send the command code 60. You have to send a 2 bytes of CRC, and you get back the output as 8 bytes. So in order to use this command and CRC, you have to look into any similar command in the library. So I'm not going to go through that in detail now. So it's really easy. Okay, that's what I have done in one of my software. So what this command returns is a 8-byte number, and this number tells you what type of tag it is. Say for example, you want to know whether you are using the L11 or L21, so you should look for the storage size, because all of the information is the same for both type of cards. So likewise, you got command to read command. I think this is the best command to, if you want to understand. If you look in the library and check for the code how this command 30 is used, so then you'll get an idea about how to introduce your own commands. So in fact, you don't have to do any coding. Everything is there in the library. You just have to know how to call these various functions. So this information about what happens when you try to read a page that is password protected, and there's also information about what kind of what if you try to access a page number that is more than the available number of pages. So as you can see here, the password and path values can never be read out of the memory. When reading from the pages holding those two values, all 0 bytes are applied to the PCD. So here the PCD means your Arduino or any kind of a microcontroller. It could be PC as well. So there's some information about that. Fast read, this is a command available um, or supported by Ultralight EV1, where you can ask for data from more than one pages. Again, in order to, you can use this. In order to use that, you need to know how to send this command number 3a. the start address, end address, and the CRC. And what you get is some number of bytes depending on how many pages you asked for. One thing that you bear in mind is you cannot try to read the entire page, because we are using, if you're using MFRC 522 as your RFID reader writer, so MFRC 522 has got its own limitations on the buffer size, so you have to keep in mind. I think probably I have tried reading up to 4 pages at a time, and it's I'm able to do it, something like 32 bytes. So the next thing about write, so using this command you can write a single page. So as you can, the command is very easy to understand here. It says you have to send the command as A2, this is a command code, and the address, which page address you want to write, and the CRC, and is because you're writing one page at a time and one page has got 4 bytes, you have to send 4 bytes of data, and depending on whether the write is successful, you will get the response, which is a 4-bit value. Again, the library tells you either a success or a failure, so you don't have to worry about the values of NAK. So the reason why you might get NAK is probably you're trying to write to a locked page. We have seen in this particular tag you can lock certain pages from writing, or it could be a password protected page and you're not authenticated yet. So there could be various other reasons as well. And there's information about what happens when you try to write it to um, a protected page here. The next is the compatibility write. So this is something to keep this card compatible with the previous versions of the card. So if you already know or if you already used Mifare Classic 1K or 4K, where the write operation takes 16 bytes, so you can there instead of a page you have got something called the blocks, so you can still use those kind of commands. So however, as the description says, even though you send 16 bytes of data, only the first byte is used and the remaining 3 bytes are ignored. But it also says that the remaining byte should be set to 0 as well. So I don't use this command often because I already have a write command, so I can use that, but you can still use this. So it's mentioned here the data is 16 bytes, only the least significant 4 bytes are written. Sorry, it's a one page, sorry, I was wrong. It's a 4 byte, the least significant 4 bytes are written, and the remaining 12 bytes are discarded. And this command is used for reading the counter. Again, we know there are 3 counters, so obviously there must be some mechanism to indicate which counter we are reading. So you start with the command 39, the address is 00 and 202, and you send the CRC, and you get 3 bytes of data as a output. So again, 3 bytes is a 24-bit counter. And yeah, this command is used to increment the value of the counter. You can, as we know from the documentation, these are like a one-way counters, you can only increment, and this is the command you have to use. So in order to use this command, you have to send this command A5. Again, this increment counter is not part of the library MFRC522. However, you can easily introduce this as a new command. The address and the incremented value. So you can pass a maximum of 3 bytes here. And there is some information about what happens when the value of the result um, goes beyond 24-bit. So this information over here is very obvious, so obviously it has to be an error. And so after that, the password authentication. Yeah, this is one of the important commands. This is the only reason why I think people should use EV1, because it allows you the password protection. Okay, so this command is used to authenticate. Assume that we have set um, the page number, like for example, page number 10 onwards is password authenticated. So you can use this command to authenticate. To use this command, you send this command IB, the 32, the 4 bytes of password, and the CRC. And if the verification is successful, that is, if the password matches what is written on the card, you get the value of the pack. So it's as simple as that. So again, this read signature. So as we know, there's a new feature. It's called to check the originality of the card. You can send this command, read signature. You get a 32 bytes of data here. So probably I still can't figure out how to verify this, but you can see when you send this command, you still get some 32 bytes of data. The check tearing event, I still don't know how it works, but you can just send it from the programmer's point of view. Just send this command and you get some values there. And VCSL command, as I said, this command when you send, you'll get the value of the VCTID, and you can use this for your application. Again, it's very clear here. So you just have to send. Uh, just don't know. You can write some number, 16 bytes, and something. It's not very clear, but you can just follow the instructions, send data what is required here to get a value of VCID. And I think that's all. After that, you got everything about hardware, and I think that's it. The next video, I'm going to show you the working of this card using MFRC 522.